Alright, welcome to 9.3, polar and rectangular forms of equations. The main thing of this is we're going to be converting back and forth between rectangular and polar. Um, to convert from polar to rectangular, here are the formulas. X equals r cosine theta and y equals r sine theta. Now, why does that make sense? Well, if I had this line right here, right, where we label that r, cosine theta would be what? The x value over r, right? And if you multiply both sides by r, you'll get r cosine theta equals x. Same sort of with y and your sine value. So let's do a couple examples here. We got point -6 comma 120, and we need to find rectangular coordinates. So simply put, remember from previous sections, it's r comma theta. So if I just do x equals -6 cosine 120, y equals -6 cosine, or sine 120, what would you get? Well, hopefully you would get, remember unit circle, 3 comma 3 root 3. This one over here, x equals 5 cosine pi over 3, y equals 5 sine pi over 3. Once again, unit circle, you will get 5 over 2 comma 5 root 3 over 2. Finally, one more. We got x equals -3 cosine 45. Y equals -3 sine 45. And what would you get? -3 root 2 over 2, comma, -3 root 2 over 2. Next, we got rectangular to polar. And here are your equations above. R equals square root of x squared plus y squared, and theta equals inverse tan of y over x. Let's do an example. We got point V, which is 8 comma 10. And that will get us approximately 12.1. And, then after that, inverse tan of 10 over 8, which should get you 0.9. And so if we need to find two pairs, so we found one, 12.81, comma 0.90. And then to find another pair, just similar to what we did before, if you flip the r value, you can just add pi, or 180, depending on if it's in degrees or radians. We're in radians because it's 0.9, so we'll add pi, which will get us 4.04. And for the other one, -9 squared, -4 squared, and that will get you 9.85, and then inverse tan of 4 over 9 will get you 3.56. So we have 1 point of 9.85, comma 3.56. Once again, flip sign, add pi. Or you can subtract pi, either or. I'll subtract pi in this case. You get 0.42. Alright, so what's the graph of this going to be? This is the first part of the question. Hopefully you remember it's a circle. Pretty neat, huh? So from here, we need to write in polar form, right? What's x equal to? As you hopefully remember, it's r cosine theta. And y is what? R sine theta. And we distribute and FOIL and all that fun stuff. And you will get the following. And then 9's canceled away. Then I can move this 6r sine theta on the other side. And then I can factor out an r squared over here. Why would I do that? Because hopefully you remember, that should be a sine squared, my apologies. Cosine squared theta plus sine squared theta is equal to 1. So then you'll get r squared is equal to 6r sine theta. Go away r, you have r equals 6 sine theta. That's your answer. Now we have an equation in polar form, and we're going to rectangular form. This can get a little dicey a little bit, okay? First one here, we're going to square both sides. We can't do anything with it yet until we square both sides. And then you should know what r squared is equal to. What's r squared equal to? X squared plus y squared. That's it. So the tough part about this part is we have to kind of play with the equation a little bit more. So we have theta. What do we know about what's theta equal to? We know what tangent theta is equal to, right? So if I put tan to both sides, tangent of pi over 3 is root 3. And then what do we know about tan theta? What's tan theta equal to? It's equal to y over x. Multiply both sides by x, you get y equals root 3x. And finally, r equals 3 cosine theta. If I multiply both sides by r, I'll get r squared equals 3r cosine theta. What's r cosine theta equal to? It's equal to x. So r squared equals 3x. And then what do you know about r squared? It's equal to x squared plus y squared equals 3x. Move that 3x to the other side. X squared plus y squared minus 3x equals 0. I'm not going to expect you to go fully standard form, but you should recognize, hey, this is a circle. Just like the previous one, you should know it's a line, and then circle for the first one. Appreciate you watching, and we'll see you later. Bye-bye.